Hi, welcome to Visual Studio Toolbox. I'm your host, Robert Green, and joining me today is Nick Karpinsky. Hey, Nick, how are
Hey,
you?
Robert. Good, yourself?
Very good. So, as we were prepping for this, Nick was saying that he was hearing a lot of feedback and noise from my microphone. So, if you guys are also hearing that, then add a comment. Let me know. I think I sound fine. Nick, I sound terrible. So, let me know, and if it really is me, I'll minimize my talking, which I'll probably do anyway. Today we're going to talk about understanding and fixing app performance, and there's no better person to talk about this. There is audio feedback. Oh, okay. All right. Sorry about that. I'm not quite sure why. So no better person to talk about this than Nick. Um, Nick, why don't you introduce yourself, and then you're going to
Yeah,
taking over because apparently I sound terrible.
for sure. I got it. So I'm Nick Karpinsky. I'm the dev lead for the Visual Studio Profiler, the diagnostic tools while debugging, and our most recent thing, the new Copilot Profiler Agent. And my team's kind of charter, if you will, is to try and democratize diagnostics. We want to make it so that everyone can go and improve the functionality of their code, both from a functional perspective and from a performance perspective. And so I I've been a part of implementing a bunch of features in Visual Studio, from profiling unit tests to profiling benchmarks to just profiling apps. And the latest thing that we've been working on has been our new profiler Copilot agent. And with this, you can basically ask the agent to help you optimize your code, and it's going to walk you through all those good steps of doing a performance investigation, such as creating a benchmark, establishing a baseline, and then iterating on different experiments on your code, and then validating those experiments to see, did they improve the performance or did they go and regress the performance?
Cool. So give us a little background as to how you decided to do this and how you implemented it.
Yeah. So what happened is I've done a bunch of blog posts in the past of, how do I optimize various open source libraries? And I go through, doing a proper performance investigation. So establishing a benchmark, measuring the performance, making some changes, and then measuring the performance afterwards. And we want to really help democratize that. We want to get it so that everyone can do kind of that workflow. And so what we ended up doing is basically codifying that workflow into an agent in Copilot. And so you can talk to the app profiler agent, and it will help guide you through that workflow that a performance expert might do. Even though you don't have to be a performance expert, it'll show you how to do that. And then for those that are performance experts, it really just takes away all the busy work or all the toil.
Mm-hmm. And was it hard to implement using Copilot?
Yes and no. All development with LLMs is interesting, and I feel like it changes every day a little bit. The actual implementation of the code, we definitely hit different challenges, but we've been able to work past it, with Copilot and with a bunch of the smart devs that are on the team. There's definitely some kind of tweaking of prompts that have been really interesting, and then we've put a bunch of smarts into the profiler agent that let it do different types of investigations and analyses. So there's definitely a lot more to it than just like collect a performance report and throw all the data at Copilot. We've gone ahead and we've helped it kind of curate different insights out of the data and then give it access to the source code so that it can then go and check different hypotheses and then go and actually make a performance recommendation.
Cool. So you want to do a demo? In the meantime, I'm going to try and fix my mic.
Yeah, for sure. I'd love to. Okay, so right here I have the CSV helper project. I've previously added in CSV helpers benchmarks project to it, and I had created a benchmark enumerate records benchmark. And I'd use this and the profiler to go and improve the performance of actually enumerating all the records in a CSV helper in a CSV file. And this project is in the top 100 projects on NuGet, so super popular package used by a ton of people. This is for reading the benchmarks. I want to see if we can go ahead and try and use the profiler agent today to go and optimize actually writing out the benchmarks. And so I can do that by switching over the Copilot chat, and I can talk to our new profiler agent. So at Profiler lets us talk directly with the agent, and then I can say, write a benchmark for the hash write records. And so what the hash does is it says it allows me to specify specific reference data to pass to Copilot. And so I'm saying I want to create a benchmark for the write records method. Just create the benchmark and make sure it builds, don't run. You don't have to put that second part there. I've just noticed that Copilot has been very eager recently to go ahead and run my benchmark and try and optimize code. I like it to stop at each stage so I can give it feedback on the actual benchmark that it's written. I can make any changes that I want, and then I can kind of move on with that. A couple of other things I want to point out. I'm just using the GPT-4.1 model. You can use a bunch of different models with the Copilot Profiler Agent. I prefer 4.1. Fortunately, it's the free one as well. It really kind of listens to the things that I'm telling it to. It doesn't necessarily go off and try and invent its own new stuff a lot. So that's why I prefer it. And have coworkers who use the Sonnet models, some of the newer GPT-5 models. It's really up to you on which ones you want to use. But as I've been kind of chatting, it's gone ahead and it's created this new benchmark write records benchmark. And you can see it's gone ahead and it's created some test records. It looks like it's creating 1,000 records. I want to go ahead and I want to say, you know, this is where I can do the edits, which is really nice. I want it to give me 10,000 records, let's say. And each of these test records have an int and a string. Let's say, and this is where I can kind of use the inline and I can kind of work with the different features of Copilot in VS, which is really, really kind of changing my workflow. So now I can say, let's add another int and string field. Please update the setup method accordingly. And then I can give Copilot little tasks. And so this is why I kind of put that thing at the beginning that was like, hey, please don't go ahead and run the benchmark because I want to go ahead and I want to review what it's doing and I want to give some input. And so I can really come to Copilot with the thoughts and the ideas, and it can really kind of take care of the actual implementation. So you can see it added an age and an address to our test record. It really doesn't matter what the fields are. We just want to make sure that it can actually write them. And then you can see it creates a new string writer, CSV writer, it writes the records, and then it flushes it out. There's one more change I want to make, which is use a pre-allocated string builder so we don't incur re-alloc costs during benchmarking. And so what I've asked it to do is instead of using a new string writer each and every time, I'm going to have it use a new string builder. It gave a large capacity. This is close to what I wanted. I'm just going to go ahead and kind of touch this up a little bit. And say builder equals new string builder. So it's going to go ahead and it's going to allocate that builder once. And the reason why I wanted to do this is then at the beginning of my method, I can say clear. And what this does is instead of constantly reallocating new char arrays or string arrays, I think is what it uses under the hood. It's just going to allocate that once, and then each time it's just going to re-clear out that buffer. And so we're not actually recording how long it takes to extend the size of a buffer. We're instead really recording, you know, how long does it actually take to write the CSV writer, which is what we're actually interested in.
Now, is my audio any better now?
Audio is way better. It's
All right.
perfect.
I guess it's my mic. So now I'm just using the built-in mic on the laptop. Okay.
Gotcha.
So you could have, that's cool. You could have actually could you have Copilot help you write the code you just wrote while in the middle of a profiler session? Can you basically have, I don't know, is it 2 Copilot sessions going at the same time?
So you could, and we've been asked that question, like, hey, how do I let it kind of do this asynchronously? My response to that has been, we are looking at it, we're investigating it.
Okay.
I want to make sure that it works synchronously really, really well before I say, oh, go off and go work asynchronously.
Okay.
But one of the things that we are finding is that writing the actual benchmark synchronously makes a lot of sense. But once the benchmark is written, the idea of like, okay, here's a benchmark, just go off and run different experiments and see like what tweaks you want to make, I think works really well in kind of an asynchronous workflow. And so that is definitely something we're looking at.
Okay, cool.
Awesome. And so now we've used Copilot, it's gone ahead and it's written the benchmark for us. And then normally I could say like, hey, I'm going to run the profiler and I'm going to go and do a performance investigation. Copilot gives me some kind of nice follow-ups, and you can even see run the new write benchmark, run the new write records benchmark. And then I'll say, and optimize the code that it calls. And now I'm basically instructing Copilot to do what it would be that I used to do, which is, okay, go find the benchmark, hook in the profiler, get a performance trace from that benchmark, and then start digging through the performance trace. And so you can see it's gone ahead, it found the 2 benchmarks, it knows that it wants to do the write records benchmark. And then normally if you've used benchmark.net before, you would get kind of a console window that pops up and it streams a bunch of text to you as it's going and it's running through the benchmark. Instead, Copilot is kind of doing this in the background for you, and it's trying to collect all that performance data. And then afterwards, it's going to open up the DIAG session in Visual Studio for us to go ahead and analyze.
So benchmark.net is a NuGet package?
Yes, it's a super cool, it's probably my favorite .NET project. It's part of the .NET Foundation, and it's a NuGet package that you pull into your project. And what it does is it helps you run benchmarks and get statistically significant data. And so you can see this has one of the annotations for a benchmark. And what it's doing is it's running this method over and over and over again. It's recording how long each iteration takes. And then it runs enough iterations to where kind of the mean time of executing that benchmark converges down. And then it knows that it has good data. And then what the profiler agent does is when that's running, it hooks in another NuGet package called its iDiagnoser package that lets us basically pull a performance trace while it's running and then open in Visual Studio. And so you can see.
So the profiler agent brought down those NuGet packages and is using benchmark.net on that other one?
Yeah, so I pre-installed this. I pre-installed those NuGet packages, but if you don't have those NuGet packages, the profiler agent will prompt you hey, I need to install this package. Is this okay? And then you can just click yes, and it'll install those packages, and then you're kind of off to the races.
Can you use a different one if you have a preference?
In terms of a different package or a different package version?
Different packages. If you have a different benchmark you like to use, if there is such a thing.
Yeah, so benchmark.net is kind of the canonical benchmarking package for .NET, but we are adding on support for other runners. And what I mean by that is we're adding support for it to also profile and optimize unit tests. And in that case, like, there's a bunch of different unit test case runners like NUnit, MS test, stuff like that. And we know how to, profiler agent knows how to use all of those.
Cool.
So, cool. And so at this point, previously, I would look at this performance trace and I would start looking at, what are my top functions? What are my hot path? And I would try and do the actual investigation. But if we look over here in Copilot, it's gone and it's done that for us. So you can see it took 4.3 milliseconds to run the right records, and then it gives us some key findings. So it shows the majority of the time is spent in this link expression compile, which is called by this create write delegate. Another significant portion is spent in the delegate invocation around should quote. Now, this is one of the kind of interesting caveats with the Profiler agent and it using an underlying model. So we've instructed the Copilot Profiler agent that it's never allowed to try and optimize library code. It should only be optimizing user code. In this case, it's like, hey, this is only calling library code because it's seeing CSV helper, which is a super popular package. And so it's getting confused here that, oh, hey, this doesn't seem like user code. In this case, it is user code. And so we can do two things. We can say what optimizations are available, and you can edit CSV helper. This is the solution for that library.
Yeah. So it doesn't account for the fact that the source code for that is in the project.
It does, but the underlying model sometimes gets goofed up. I've had it work both ways. And so it's kind of a balancing act. Sometimes it'll get kind of goofed up like this when working on larger open source stuff. When we use this on the profiler itself, it almost never gets goofed up just because it hasn't been necessarily trained on that code. And so it's good to go. And kind of one of the nice things about this agent is you can kind of talk to it like a performance expert, and it'll go and it'll explain the different things. And so it had that follow-up question of like, what optimizations are available? And so you can see like, hey, we could reduce expression compile overhead. It's saying a large portion of the time is in this create write delegate. Ensure delegate creation and compilation is minimized and cache aggressively. Optimize the should quote logic. Optimize write to buffer, optimize delegate invocation, and then it kind of gives you some potential next steps. And so this is kind of the point where, to your comment earlier about like, hey, can you run this asynchronously? This is really that part where we're trying to get the asynchronous working, because in an awesome asynchronous world, I would say like, go try each and every one of these and like, let's have 4 copilots going at the same time. In this case, I've previously tried the, optimizing the should quote. I've previously tried the caching approach. I'm going to focus in on this 4th one, which is this delegate invocation. So let's go with option 4. What can we do to optimize this? And so it, again, now it's picked option 4, and it kind of gives that optimization plan. So it says it's going to move the lookup and type info retrieval outside the loop, only perform the delegate lookup once, and it's going through and it's actually implementing the optimization. And then the other interesting thing is it's already gone ahead and it's kicked off another benchmarking run. So one of the things I always say is like, if you're not using data, you're not optimizing, you're just refactoring. And so it's gone ahead, it's captured data, it's made guesses as to, what are things that we can optimize. It's made that change and now it's rerunning again to see, what is the impact of the change that I'm making here. And I can even click on this and then I can kind of see like, oh, what is this actually doing? So it looks like it is trying to cache the right delegate here, which looks like it might be, it looks like it might have already been doing that. So I don't necessarily know. Oh, it looks like it pulled it outside of the do while loop. Where was I? Yeah, so it's assuming each record is shaped the same. It's pulling it out of the do while, and then it is only grabbing that once. And so it had gone ahead and it reran it. It looks like it's now 4.4. So not a huge performance increase. And so not the sort of optimization that I would want to do. So I can hit undo here, and then we can try something else. Previously, there was something about multicast delegate invoke. So let's just copy that. Can you optimize the...
Could you tell it to try all 4 one after the other and then report back on which is actually better?
You can. I've had some success with it. It's one of those interesting things. I think everyone kind of has their own workflow. I like to make sure that Copilot, I stay in the loop with Copilot and I can kind of direct it. I know other people have had a lot of success where it's, they've just kind of farmed it off. It will normally, I'm kind of surprised it's gone off the rails a little bit in this demo, but normally it will say things like, oh, hey, I've actually regressed performance. Let me undo those changes. And so in that case, like if you said, go try all 4 and report back, it could try each one, revert the change, try a different one, revert the change, and then figure out, which is the most optimal one.
The nice thing about doing it one at a time is you learn things. It's pretty easy with Copilot to just say, hey, go off and do something, and oh, cool, here's the result. And then you don't learn nothing.
Yeah, exactly. And so the learning something is really interesting. I'm trying to see if I can get it towards the delegate creation, because I learned something with this delegate creation PR here, which was it found, and for some reason now it doesn't want to find, it probably knows it's on camera. It doesn't, oh, actually, I think it is finding the right one now. It found this create write delegate method in where it's actually creating these async lambdas based on the layout of the data. Yeah, it looks like it found it this time. Okay. And so what happens here is when it needs to actually write the record, it creates a little lambda that says, write the ID field, write the address field, write the age field. And then it went ahead and it took all of those lambdas and it compiled it into another method that basically invokes them one after another. And Copilot, when I originally did this demo, and fortunately now, found that instead of calling these lambdas one after another and basically incurring that function overhead each time, it grouped them all together. It created a new expression block, which is just a single lambda that writes the entire record all in one shot and then returns that. And so basically it scales on the number of fields that you have in your CSV record. And I didn't understand what it was doing. It showed me that it was faster. And so when I first did this, I was like, oh, wow, that's really interesting. And then I can ask it afterwards, like, why is this faster? And it'll start to explain it. And it's, nice and super patient with me. There are no dumb questions for Copilot. It's going to respond to everything. And so in that case, like I got to learn more about C# on something that I just didn't know about.
Right. Oh, look at that. 2.6.
Awesome.
Nice.
Yeah. And so it even shows us like, hey, we went from 4.5 milliseconds to 2.7. It's much lower. And then it kind of gives us more follow-ups. Like, hey, do we want to continue optimizing these other things? And so to your comment on the learning, like, why did using the expression .block make things so much faster? So the cool thing is like you said, like I can sit and I can learn. And the nice part is like we're optimizing at the same time. Right. And this is a real world library. This isn't like some code where I put in the slow code and I ask Copilot to remove the slow code and instead do the fast code. Like, no, this is an actual library. We staged this PR. We sent it out to the maintainer. This is going to improve performance for everyone who uses this library. And again, it's super popular. So hopefully it'll impact a lot of people.
That's cool. So obviously, as time goes on, the Profiler Agent will get better and better. So does that kind of say that I should use it today to optimize my code and then come back in 3 months, 6 months, whatever, every 3 months, rerun it and see what additional optimizations are. Presumably and hopefully you'd get less and less of an increase over time, but who knows, right?
Yeah, exactly. And especially as like .NET comes out with new optimizations, you know, there's new optimizations coming out in .NET 10. The agent's going to learn about these different tricks that it can do, and it's going to go ahead and optimize stuff. I've seen it use SIMD vectorization on code, which is, I understand the concepts behind it. I couldn't write the code myself. I've seen it do cute stack allocations where it avoids allocations. And so there's all these different optimizations that it can do. And so, yeah, as like new things in .NET come out, you should definitely try it. As the agent gets better, it's going to get better and better at optimizing code. And now and once you've actually created the benchmark, the thing that we did at the beginning, like that's an artifact that goes with your repository now. And so you can always have it and you can run it again in the future.
Is there the ability to have this run automatically as a GitHub action? So I check in my code and then the profiler agent runs and makes changes, or do I have to, is it automatable or do I have to be part of the conversation?
So at this point, it's not automatable, and I will say yet.
The automation throwing all kinds of things for you to add to the product.
Yeah, no, I mean, it is absolutely something we're trying to add. We have benchmarks running automatically in the profiler's code base. So we're kind of cobbling it all together, and we're trying to see like, hey, where does this work? Where doesn't this work? And kind of, you know, what are the tweaks that we can do? So it's definitely, we're trying to build that scenario right now. Cause yeah, it would, you know, it's awesome. The idea that like I could check in code and then, you know, go home for the night, and I come in the morning and Copilot is like, hey, I was running your benchmarks last night and I found this optimization for you. Would be just awesome.
Cool. All right. What's next?
Cool. So these are kind of the main things that I like to do with the profiler agent. This is, you know, how I will run it, and I just try it out on different code, you know, blocks of code, and kind of keep repeating. I've continued to run it on this library. I've run it on other libraries. It also works in things that are not libraries. I don't have a demo of that today, but if you just have, let's say, like a desktop app, like even Visual Studio, we've started to run it on. It can run just the profiler. It doesn't necessarily need a benchmark, and then it can go and try and optimize based off that. And then it'll even see like, oh, these are the methods that are on your hot path. Let me go ahead and try and write benchmarks for those methods.
Cool. So you guys watching, if you have any questions, don't forget to ask.
No.
Audio is almost as bad as File Explorer performance.
Well, we will try and see if we can run the profiler agent on File Explorer.
That's hilarious. All right. Anything else you want to show?
Those are the big things. The other kind of, I'll put in a couple of other small plugs and tweaks. So we had if I can find my benchmarks, another kind of small thing we've added is we have a optimized code lens now. And so you can click into this and you can automatically jump into the code lens for optimizing for CPU or performance. This just jumps directly into the profiler scenario. I can try and run that. Let's go ahead. We'll just keep this. We'll start a new conversation. And then we can hit something like optimize allocations. And you can see it jumped a bunch of the steps that I would previously do, which, you know, instead says, hey, run this benchmark and optimize the allocations of the code that it calls. It's just kind of a fast path into that scenario. And it's one of the two types of investigations we support. So the first investigation that we did was a CPU investigation. The second investigation is an allocation one. Typically, whenever you trim down the number of allocations that you're doing, CPU performance also increases.
So I've been playing around with having Copilot write apps for you. So I had it write an app, excuse me, and it's done 98% of the coding. I've popped in every now and then and asked it to do something different, but it's basically a Copilot written app. Now I'm going to run the profiler on it and see if it likes the code it wrote for me.
Yeah, I mean, you definitely should. We actually, one of my teammates vibe coded a Godot game called it was after another game called Vampire Survivors. I forgot what he called his. But your little character walks around and he shoots fireballs at all the different enemies that were on the screen. Copilot vibe coded it, and then afterwards he asked the profiler agent, like, hey, go and optimize this code. And profiler agent attached to the game, it found a allocation that was occurring with how Godot manages string names. It's weird. They have like a weird string and turning system that they use. And what it ended up doing is it created a benchmark that ran the Godot engine and actually got it shooting the fireballs, and then watched memory allocations go up, found where the allocation was occurring, found it different overload to use, tweaked the code ever so slightly, and then all of a sudden allocations were stable. And it's one of those interesting things where it's like, oh yeah, Copilot vibe coded this code. It turns out that, like, yeah, it had a performance issue. Like, the code worked, it was functionally correct, but there are ways that you could make it more optimal. And then the profiler agent was able to go ahead and instead look at it with a performance lens and see, like, oh, hey, we could trim this out, we could do this other thing, and it's actually faster.
So is it safe to assume that the more profiler agent gets better at optimizing code, the more Copilot would get better at writing the code in the first place, because it will eventually learn more about performance of code? Is there a virtuous cycle that will go on eventually?
Ideally, yes. we're definitely we're hoping that's the case. I know we've talked about the concept of kind of multiple agents going after something, and so maybe when you're actually vibe coding, the Copilot vibe coding agent turns around and says, like, okay, I actually coded it. Now, profiler agent, like, just do a once over on this code and make sure I'm not doing anything egregious, right? And can go and kind of fix stuff.
Does the vibe coder eventually learn from the profiler? I mean, is it all one big model? Is it multiple models? How does this work behind the scenes?
I mean, behind the scenes, it can work with any number of models. And so the profiler agent itself is kind of on its own island, and it knows how to talk to the different models. Okay. And then there's an idea that, like, the different agents could kind of talk with each other, and they could each be using their different models, if you will.
But there's no way for the profiler agent to feedback what it discovers back into the model so they don't write less performant code in the first place? Is that
not yet? Okay. Not yet. So
okay.
Looks like so allocation traces, I'd click this off while we were kind of chatting. Allocation traces definitely take a bit longer to actually capture and then go ahead and analyze. But as we've been kind of chatting, you can see, like, it's gone ahead and it's captured a bunch of allocation information. We can look at the number of allocations that occurred. And the allocation tool is a little heavyweight because it captures each and every allocation that happens in the benchmark or whatever it is that you're profiling. And so you can see, like, we had 3 million string allocations, or we had 1.6 million enumerate records allocations, and 1.6 million int allocations, which the int allocations are really interesting here, because if you see an int allocation, an int is a value type, not a reference type, which means it actually got boxed and put out on the heap. And so this would be the sort of thing that I, as a performance person, would, like, immediately see and be like, oh, hey, maybe our API is a little, wrong here, and, like, we should make some tweaks, because ideally we're not boxing all of these ints. And this is the sort of information that we also feed to the Copilot Profiler Agent. So it sees those sorts of things and is like, oh, hey, let me see what I can do to try and optimize that.
Cool.
So, yeah.
This is such an awesome tool.
Yeah, it's a really, really neat tool. It's super, super powerful. I mean, the profiler is super powerful itself. The kind of challenge with the profiler, and that we've heard from users, is like, it's a lot of data. It's super intimidating. I don't necessarily know what it is that I'm doing or what it is that I'm looking at. And like I said earlier, my team's kind of motto or kind of mission is to try and democratize diagnostics. And so the profiler agent, it can really help you kind of understand and pull some insights out of these profiling traces, and then it can answer the questions that you have about the traces.
But you can almost think of it as just another advanced feature. I mean, advanced features come out all the time, whether it's in the language or whatever. And, you know, the first time, you know, we thought about async or delegates, right? I have no idea what I'm doing, but then you learn more about it and you become comfortable with it, and it becomes just a tool you use. So yeah, this is very intimidating and there's an awful lot going on, but it's an advanced feature. And a year from now, you'll be, or hopefully less, but you know, next time you come back and say, well, I better understand it. And the more you do it, the better you understand. And, you know, at the end of the day, if it recommends something and you don't understand it, but it cuts performance by 15%, okay. I mean, that, in a lot of ways,
I'm not going to argue with free performance.
It's so different than, you know, me sliding my chair over to you and saying, hey, what's wrong with this code? And you go, oh, you should do this. And you type a bunch of stuff and it's more performant. And I say, thank you, and move on, right?
Exactly.
Cool. All right. Any questions from the viewers before we wrap up? Doesn't look like it. All right. Thank you so much for coming on and showing this to us. This is amazingly awesome.
Yeah. Of course. Thanks for having me. It was fun. And
everybody try it and keep sending that feedback. This will get better and even better and even better, right?
Yep.
Awesome. All right. Cool. Hope you guys enjoyed that. And we will see you next time on Visual Studio Toolbox.